y equals sine of theta. This theta is the same thing as sine of x. As we know, in the first quadrant, when x equals 0, sine 0 equals 0. Sine 30 degree equals 1/2. Sine 90 degree equals 1, so it's increasing. And from pi over 2 to pi in the second quadrant, sine is decreasing to 0. And then in the third quadrant, sine becomes negative, and the last quadrant, sine is also negative. So this is the graph from 0 to 2 pi. So similarly, it's symmetric about the origin. So from negative pi over 2 to pi, this is the graph. If we look at the domain means the interval for x. X can be all real numbers. So you can write down all real numbers or negative infinity to positive infinity. And the range is the y value. So the y can be from -1 to +1. Similarly, for y equals cosine of theta, when x equals 0, cosine 0 equals 1, and it will decrease in the first quadrant, and cosine pi over 2 equals 0. So that's a graph. And then second quadrant, cosine is negative, -1 here, and then negative in the third quadrant, and positive in the fourth quadrant. It's symmetric about the y-axis. So from negative pi over 2, from negative 2 pi, this is the graph. Okay, we will look at the domain and the range. The domain will be all real numbers, and the range will also be -1 to 1. So now let's have a look at the graph of tangent of x. Tangent of x, as we know, tangent of x equals sine of x over cosine of x. That's why whenever cosine is 0, the tangent will be undefined. That's why we are going to have asymptotes. At 90 degrees, -90 degrees, all the 0, we are going to have asymptotes. And tangent theta, when theta equals 0, that's 0. And will be the graph will look like this, and it's repeating. Tangent pi equals 0, because sine pi equals 0. Tangent negative pi is also 0. And from here, the period here for sine of theta equals 2 pi. The period for cosine is also 2 pi. However, the period for tangent equals pi. The period means it will repeat. After pi, it will repeat the same picture. So let's have a look at the domain. The domain is for the x values. If you look at the x value, x can be anything except the vertical asymptotes. If you look at the vertical asymptotes, how do we write the equation of the asymptotes? So x is vertical, so x equals what? If you look at the value, so it's pi over 2, negative pi over 2, 3 pi over 2, 5 pi over 2. So will be pi over 2 plus n times pi. You keep adding pi. And n can be 0 plus -1 plus -2, etc. Just any number. And given two specific asymptotes, you can choose n equals 0, so it's pi over 2. N equals -1, which is negative pi over 2. So x equals. So the domain will be all real numbers. Except x equals these asymptotes. And the range, if you look at the y value will be from -infinity to +infinity. So all the trig values, the trig functions, they are periodic functions. So that means after a certain amount, the graph will repeat itself. Let's have a look at cotangent. So cotangent of theta equals cosine over sine. So whenever sine is 0, that will give us asymptotes. When sine equals 0, so that means when x equals 0, pi, 2 pi, negative pi, negative 2 pi. So if you look at the asymptotes, the equation for the asymptotes will be x equals n times pi, and n can be 0 plus -1 plus -2. So it can be 0, pi, 2 pi, 3 pi, 4 pi. And two specific one will be x equals 0 and pi. And the graph is very similar to tangent of x, but it will be decreasing. So from 0 to pi, when when theta equals pi over 2, cosine equals 0. So the graph will look like this. So pi over 2, 3 pi over 2, all these points are 0. So the domain will be all real numbers except x equals n pi, the asymptotes. And the range, infinity, negative infinity to positive infinity. And of course, the period here for cosine is also pi. Okay, now let's have a look at secant and cosecant. For secant of theta, as we know, secant equals 1 over cosine of x. So secant of theta will be very similar to tangent. Whenever cosine is 0, your graph will have asymptotes. So cosine equals 0, that means pi over 2, negative pi over 2, 3 pi over 2, and negative 3 pi over 2. Let's have a look at the graph. So because it's 1 over cosine, this is a graph of cosine. So whenever it's 1, it will be 1. Whenever it's negative 1, 1 over negative 1 is also 1. And because it's 1 over cosine, so when it's decreasing, it will increase. So the graph is like this way. Because it's negative here, it will go here. And it will go here like this and this. If you look at the period here, if you see after this much, it will repeat the graph. So the period here for this function is the same thing as cosine. The period is 2 pi. Similarly for cosecant, also the period is 2 pi. Let's look at the domain. Domain should be the same thing as tangent, right? All real numbers except the asymptotes. Except x equals what? Let's look at the equation. X will be pi over 2 plus n pi. And it's 0 plus minus 1 plus minus 2. So the two asymptotes will be pi over 2 and 3 pi over 2. That's secant of theta. And the range will be, if you look at the range, x, the y value has to be negative infinity to negative 1 and 1 to infinity. It cannot be, nothing is between negative 1 and 1. Let's have a look at the graph of the cosecant. The cosecant here is 1 over sine. Whenever sine is 0, it's undefined. So the graph, the asymptotes should be the same thing as cotangent. The asymptotes here at 0, pi, 2 pi, negative pi, negative 2 pi. And whenever sine is 1, the value is 1 over 1, give us 1. So let's label those points. So sine pi over 2 is 1. Sine 3 pi over 2 is negative 1. Okay, sine negative pi over 2 is negative 1. And sine negative 3 pi over 2 is positive 1. And also, the graph will be going up because it's negative here, so it's negative. Because it's negative here, it's going down, it's going up. So the period is still 2 pi. The domain will be all numbers except n pi. The equation will be n pi, n equals 0 plus minus 1 plus minus 2. And the specific asymptotes will be x equals 0 or x equals pi. And the range, same thing. Everything except -1 to +1. So these are the basic 6 trig functions: the graph, the period, domain, and range. Okay, next we are going to go over the trig values. Trig values are very important. If you watch my video, you can, as long as you know the reference angle and the value is in the first quadrant, they should be very similar. Let's have a look. So tangent of 60, I'm going to show you different ways to solve the problem. So first, tangent 60, if we remember the table, this will give us square root of 3. If you don't remember the table, you just draw the triangle. So this is 30-60 triangle. So this is 1, 2, radical 3. Tangent 60 equals, tangent equals opposite over adjacent. Square root of 3 over 1 give us square root of 3. So let's look at example 2. Sine 202, 50. You can draw the triangle here. So this angle will be 45 degrees. So this is 1, 1, radical 2. However, x is negative here. So sine equals -1 here too. -1 over square root of the root give you this. Also, you can use reference angle. Sine 225 equals sine 45 degrees because its reference angle is 45. However, in the third quadrant, all students take calculus, so sine is negative. So as we know, sine 45 is radical 2 over 2. Sine 90 degrees, we can use the definition. So sine is opposite. Right, this is x, y, r. Sine is opposite over hypotenuse. So opposite, which is y over r, y over r. If you look at here, y and r is the same, so sine 90 is 1. Or we can use the table directly. So like this one, cosine 150, I'm going to use the reference angle. Reference angle 30 degrees, cosine 30. So because all students take calculus, it's negative. So it's negative square root of 3 over 2. Cosine 90 degrees. Also, you can use the graph. Cosine 90 equals 0. Also, cosine equals x over r. So x equals 0, that's why. So tangent 240, if I use reference angle 60. So this will be equal to tangent 60. All students take calculus, so tangent 240 should be positive. So positive square root of 3. Cosine 135 equals cosine 45. This is 45. The second quadrant, negative. Tangent 150 equals tangent 30 degrees. Second quadrant, negative equals negative square root of 3 over 3. Or you can use the triangle. So 30-60 angle. So 1, 2, radical 3, negative here. Cosine 270. You can use the table, you use the graph, or you can use the definition. Cosine equals x over r. X equals 0, so that's 0. Tangent 225. Tangent, I'm going to use reference angle 45, positive, so it's 1. Positive 25. So if there's no picture, of course you can draw a picture yourself. Cosine 270, right here is 0. Sine 0 equals 0. Cotangent equals cosine over sine, or it's easier if you draw a picture. 7 pi over 4, almost 2 pi. The reference angle pi over 4. So directly equals cotangent pi over 4. All students take calculus, so cotangent negative. So -1. Cosecant, we'll change it to 1 over sine, 2 pi over 3. Okay, sine 2 pi over 3 is in the second quadrant. Sine positive, so it's the same thing as sine pi over 3 equals 1 over sine 61 square root of 3 over 2. So 2 radical 3 over 2. Cosecant 225 degrees. 1 over sine 225 degrees. Sine 225, the same thing as sine 45, but third quadrant, negative. So it's negative radical 2. Sine 300 equals sine reference angle 60, last fourth quadrant, negative. So it's negative radical 3 over 2. Cosecant 90, 1 over sine 90 degrees. Sine 90 is 1, so it's 1. Tangent 240, so it's the same thing, tangent 60 degrees, third quadrant, positive. Tangent 60, radical 3. Sine pi over 2, special angle, radical 2 over 2. Tangent 120, tangent 60, negative, negative, radical 3. Tangent negative 13 pi over 6. So this one is bigger than 2 pi, so first we can add 2 pi here. So equals tangent over 6. Because the period is pi, we can add 1 pi, add another pi. So make it tangent negative pi over 6. Of course, if you don't like the negative, you can change it to negative pi over 6 in the fourth quadrant. Reference angle pi over 6, negative, give us tangent 30, negative radical 3 over 3. All these big values, you can use the period. You can keep adding. So this one I'm going to add 360 times 2 because period is 360. So 720, so this is cosine 90 degrees, which is 0. Cosine 990, I'm going to keep minus 360 times 2. Give me cosine 720, which is 270. Cosine 270, as we know, it's 0. Cosecant, so first we are going to change it to 1 over sine negative 31 pi over 6. We can add. So if we add 6 pi, so 6 pi over 6 give us sine 1 over sine 5 pi over 6. 5 pi over 6, second quadrant, reference angle pi over 6, positive, sine 30, 1/2. So 1 over 1/2 give us 2. Cosecant negative 1 over sine negative 5 pi over 6. So you don't have to add because we know negative 5 pi over 6 in the third quadrant. Reference angle pi over 6. All students take calculus, so it's negative. So negative 1/2, so it's negative 2. You can solve it different ways. You can, of course, you can add the period and make it positive. It's up to you. So cosine negative 17 pi over 2, 3. I can add 6 pi, which is 18 pi over 3. So give me cosine pi over 3, cosine 60, which is 1/2. Sine 29 pi over 6 equals sine 29 pi over 6 minus, I can minus 2 pi, I can minus 24 pi over 6. Right, that's 4 pi. So give me sine 5 pi over 6, which is 1/2. Second is 1 over cosine. Because this angle is big, we can minus 945. We keep minus 360 times what? Times 2. So 720. So it's cosine 225. 225, third quadrant, reference angle 45 degrees. And it's negative. So it's negative radical 2. Cosine negative, we can add. We can add 12, that's 6 pi. So it's cosine pi over 2, cosine 90 degrees, which is 0. Sine negative 2 pi, sine negative 2 pi, which is always 0. Let's have a look at the inverse trig functions. So the inverse trig functions give the domain and the original function that we use to make the inverse into a function. So as we know, the graph of sine function is from 0 to 2 pi. In order for the function to have inverse function, it has to pass a horizontal and vertical line test. So because the periodic function is impossible to pass the horizontal line test. So we are going to limit the function. For sine, in order for sine to have inverse functions, we limit, okay, x is from negative 90 degrees to 90 degrees. So for cosine, in order for cosine to pass the horizontal line test, we limit x from 0 to pi. Similarly for tangent also periodic function. In order to pass the horizontal line test, we limit x has to be from negative pi over 2 to pi over 2, open interval. Okay, you can have a look at the graph using your calculator, but this is super important. So just sometimes we use sine inverse or arc sine of x. They mean the same thing, means the inverse of a function. So the inverse of a function give us an angle. Let me go over this domain range briefly. So for sine of x, the domain will be all real numbers, and the range will be from negative 1 to positive 1. So for y equals sine inverse, as we know, so for the inverse function, domain becomes range, range becomes domain. So domain will be negative 1 to 1. However, in order for sine of x to have inverse functions, we limit the angle has to be from negative pi over 2 to pi over 2. Similarly, for cosine, negative infinity to infinity, range negative 1 to 1. So cosine inverse, domain negative 1 to 1, and the range will be 0 to pi. Tangent of x, domain all numbers except, and the range will be all real numbers. For tangent inverse, domain range, we limit the range. The angle will be from negative pi over 2 pi over 2. Let's go over some questions here. So sine of inverse. So first of all, you know all these inverse functions give us an angle here. So sine inverse of 1/2. So the answer has to be from negative 90 to 90 degrees. That's a definition. So sine what give 1/2? Sine 30 degrees. Cosine what give you 1/2? Has to be from 0 to pi. First two quadrant, cosine of 60 degrees give you 1/2. Tangent of what gave you square root of 3 over 3? Tangent 30 degrees. So cosine of what give you square root of 3 over 2? Cosine 30 degrees. Or pi over 6. It's up to you. Sine of what give you square root of 2 over 2? Pi over 4. You just need to keep in mind, sine inverse give you an angle between negative pi over 2 to pi over 2. This has to be satisfied. Tangent of what give you 1? Tangent pi over 4. Tangent inverse give you an angle between open interval negative 90 to positive 90. So we don't have this inverse. Arc sine negative 1/2. Okay, so sine 1/2 give us 30. Negative give us negative 30 degrees. Okay, cosine inverse, cosine of what give you negative? You see the first two quadrant has to be an angle in the second quadrant with reference angle. Cosine 1/2, this is 60, so this will be 120 degrees. So first, we don't have to worry about this negative. This negative only give us which quadrant it is. Tangent what give you negative? So negative 90 to 90, this angle has to be here in the fourth quadrant. So tangent of what give you square root of 3 over 3? This reference angle should be 30 degrees. So our final answer, negative 30. Number 10, cosine negative. So because cosine inverse give you an angle first two quadrant, however, cosine is negative, so the angle has to be here in the second quadrant. So now this negative is taken care of. Cosine what give you square root of 3 over 2? As we know, cosine is 30 degrees. So the reference angle is 30 degrees. So the real angle is 150. Or if you are familiar, you know cosine 150 give you negative. That's fine too. So sine what give you negative radical 2 over 2? It has to be in the fourth quadrant. So it's a negative pi over 4. Tangent of what give you negative 1? So negative pi over 4. Fourth quadrant. Sine what give you 0? That's 0. Cosine what give you 0? Pi over 2. Tangent of what give you negative radical 3 has to be in the fourth quadrant. Square root of 3, which is 60 degrees. So it's negative pi over 3. Sine what give you 1? Pi over 2. Cosine what give you 1? Cosine 0. Tangent what give you 0? 0. Sine of what give you negative 1? Okay, keep in mind it has to be from negative 90 to 90, so it's negative pi over 2. Cosine what give you negative 1? Cosine pi. Okay, so the next lesson you can go over these examples and you can solve the problems yourself. Let me go over some of the problems. So if you look at the answer, okay, so first, how do we solve equations here? So minus 4 on both sides. So cosine equals 1/2. Cosine from 0 to 2 pi, we have two values equals 1/2. Cosine 60 degrees equals 1/2. Right? If you look at cosine from 0 to 2 pi, there are two values. One is here, one is here. So the easiest way for me is, as we know, cosine has to be positive. So you have one here, one angle here, with the reference angle pi over 3. So you can write your answer as pi over 3 and 5 pi over 3. Same thing, sine equals 1/2. Sine equals 1/2 from 0 to 2 pi. We have here and here two angles. And the reference angle pi over 6. Okay, so first combine all the like terms. So cosine 2x equals negative 1/2. How do we solve this? You can treat 2x as a whole term. So 2x, cosine is negative. That means we have two angles. One is here and one is in the third quadrant. So negative, okay, we don't have to worry too much right now. Cosine what give you 1/2? So cosine 60 degrees, so it's pi over 3. So the reference angle is pi over 3. So our real angle will be 2 pi over 3 and pi plus pi over 3 and 4 pi over 3. And then we divide by 2. Okay, everybody, you can try these problems. Any questions, let me know.